Hi, in this video I'd like to show you how you could use Google Sheets to make graphs of the kinematic quantities we've been learning about in Chapter 2. Specifically, I'd like to touch base again with the Prius versus Tesla race that was the subject of the last YouTube video I posted. We learned that both cars go from 0 to 60 miles per hour, which was 27 meters per second, but in different amount of time. Took the Prius 10 seconds to make that change and the Tesla only 5 seconds. And we calculated from the given information what was the acceleration of both the Tesla and the Prius. So let's make note of those things here. So for the Prius, we found that its acceleration was 2.7 meters per second. So I can keep track of this information in Sheets by entering the quantities in various cells, but I'm going to leave the 2.7 as just a straight up number cell so I can use it later in a calculation. And then I can update that for the Tesla. I'll copy it and paste it down here a little ways, Control C and Control V. This will be for the Tesla now. And its acceleration was 5.4 meters per second squared. Whoops, got that wrong. What I'd like to do is use the equations of kinematics in order to calculate for me the velocity and the position as functions of time for the Prius and for the Tesla. I do want to note that both cars start from 0, so their initial velocity is equal to 0 meters per second. Sorry. And format it like I did before. And that information is going to be the same, so copy, paste. So both cars start from rest, but they accelerate differently. Now I want to make for me a column that is a time variable that goes by in seconds, starting at 0, and then 1, and then 2. In fact, if I give Sheets enough of a hint, I can copy down by grabbing them and it fills out the rows for me. So this is going to go out 10 seconds. I can make sure that it knows it's a number. And then I'm going to want a column here for the velocity of each of the cars in meters per second. Let me move this up one because I want one column for the Prius and one column for the Tesla. But rather than calculate numbers by hand and laboriously fill out each of these columns, I'm going to let Sheets do the hard work for me. I'm going to instruct Sheets to fill out this row and cell, this cell here, with a formula. Beginning with an equal sign, you can type numbers and multiplying and dividing, and even grab cells to calculate numbers that you would like to fill. So the formula for velocity, if you remember from Chapter 2, is that the velocity at any instant in time is equal to the initial velocity plus acceleration times time. So the formula is v, which we want there, is v0 plus at. So I can start this cell here with an equal sign to tell Sheets that it's going to be a formula. I'm going to grab v0, or at least what's in that row and column there, and I'm going to add plus acceleration times time. So look at what I did there. I told Sheets to calculate for me a formula v0 plus a times t. But instead of using numbers, I told Google to use the values that are in the various cells that I referred to. There's one trick, however. It will calculate just fine with what I gave it, but I'm anticipating copying this formula down into all of the subsequent rows. And I would like Google to use always the time that goes with the row that it's in. However, always go back to these two exact cells to get the initial velocity and the time and the acceleration. So there is a way to fix cell references so that the formula updates properly when you copy it, and that is by using dollar signs. So in front of the B4, I'm going to put a dollar sign and a dollar sign. It means to sheets. Wherever I copy this formula, it will always refer to what's in B4. And I'll do the same thing for what's in B3, which is the acceleration. So a dollar sign and a dollar sign. That tells Google to always get this number and this number in the formula. But I'm going to leave E4 unspecified, fixed like that, because when I copy this formula down, I would like Google to update row 4 to row 5 when it puts what's in the next thing. So if I do that, and I copy that formula down, then let's take the 5-second mark, for example. It went back to get these two numbers for the initial velocity and the acceleration, but it used this updated row and column reference for the time. So it did exactly as I wanted. If I hadn't affixed the V0 and acceleration with dollar signs in front of the row and column indices, then Excel would have updated then when we copied them down, which is not what we want. So can tell that these are numbers and give it all decimal points. It's looking pretty good. I want to make a similar formula for the Tesla formula. So I'm going to do an equal sign, V0 plus acceleration times time, but in anticipating of copying this formula down, I'm going to fix the cell references for velocity and for acceleration. And then when I copy that down to 5 seconds, everything looks great. So I've instructed Sheets here to make a nice table for me, and I didn't have to calculate all of those numbers myself. I used Sheets and the formula capability that have in it. Let's try to make a graph of these data. So make sure that Sheets knows this is text and that these are numbers, and you highlight the things that you want to make a graph of and do your old friend insert, chart, and what pops up is a first stab at a graph. I always prefer to plot the data points and not connect the data points with line segments. And because the column headers had Tesla and Prius in it, it set a legend for me. Now, I might go and change the title to something more descriptive, like velocity versus time. Google got the label for the x-axis right, but it didn't put a label for the y-axis, so you would have to add that. Of course, I do always prefer to put charts on their own sheet so that they remain with the fixed aspect ratio, but that's not too bad. So if you're following along and want to try to reproduce this yourself, you have a good graph here, but you need to update the title and the y-axis scale, as we learned in the lab from last week. Now I do want to show you something else that's kind of useful. I could extend the Tesla column all the way down to 10 seconds and use that to answer the question, how fast is the Tesla going if it accelerated for 10 seconds? That was one of the questions that we asked and answered in the Prius versus Tesla race. 54 meters per second. That's what we got. And then when I extend that, the chart automatically updates the scale. So that's useful too. So here I have a nice graph that shows the Prius velocity as a function of time and the Tesla velocity as a function of time. And as before, we note that these two lines are straight, but they don't have the same slope, because the slope of a velocity versus time graph is acceleration, and the acceleration of these two cars is different. The other thing that might be fun to mess around with is to adjust these various parameters. So for example, what happens if I gave the Prius a bit of a head start? Since the formula that I used to calculate the velocity column for the Prius was v0 plus acceleration times time, I can update this thing and say, well, what would happen if I gave the Prius a 10 meter per second head start? Well, we can see now that the Prius starts at 10 meters per second, where the Tesla starts at 0. We can see that the slopes of these lines, they don't change at all. It's just that the Prius line is shifted up a little bit. So they end up going the same speed, somewhere around 4 seconds. So the usefulness of writing formulas that are general and letting sheets do the calculating for you is that you can change things on the fly. Okay, so let's try to do a similar sort of thing, but for the velocity, for the position. So instead of making a graph of position versus time, velocity versus time, let's make a graph of position or distance as a function of time. So I'm going to do the same thing I did before. I'm going to use a formula and instruct Google to calculate these numbers for me. The formula, however, is a little bit different. If you look in your book near the end of section 2.5, you see the formula for distance or position is v0t plus 1/2 at squared. It's a bit more complicated, but totally doable. I want to enter that formula, start with an equal sign. It's v0 times t, so I'm going to grab the v0 and I'm going to grab times the t, but I'm going to fix the cell reference for v0 because I don't want Google to update that. And then I got to do plus 1/2 at squared, 0.5 times acceleration, but fix the row and cell reference, 1/2 a times the time column squared. Looks good. Copy it down, and I have a column that tells me the position as a function of time for the Prius. And as we found, the position after 10 seconds for the Prius is 135 meters. That was the result of our calculation using the same formula during the last video. Now let's make a similar formula for the Tesla. Equals v0 times t, but remember to fix the row and column reference there, plus 0.5 times acceleration times time squared, but remember to fix the acceleration row and column reference. Excellent. Copy that down. We'll only go down to 5 seconds at this point. And we get the same result we had before, that in the time it takes the Prius to go from 0 to 60 miles per hour, the Prius takes 10 seconds and travels 135 meters. The Tesla takes 5 seconds and goes 67 or 68 meters. And then we could even ask, well, what would happen if the Tesla kept on going at the same acceleration? Well, it would end up going pretty far, pretty fast. Well, I'd like to make a graph of position versus time for the Tesla and the Prius. So here's a trick. you can highlight this column, including the header, and then I hold a Command key. It's probably the Alt key on PC, and I highlight the other columns. So it allows me to highlight 3 columns which aren't right next to one another. So the first one I highlighted normally, the range of cells I wanted, and then I held down the Command key on Mac and held down this range. But I've selected these 3 cells, and I'll ask Google to make me a nice graph. Well, here it's made a very bad choice for the nature of the graph. So I prefer the XY, and it has correctly then recognized that the x-axis is the first column that I highlighted. If that's not the case, sometimes that turns up down here. You get 3 lines and no x-axis. If that happens to you, you can select remove it from the series thing and then add it to the x-axis thing. In other words, Google needs to know what's the x-axis and what are the 2 different series to graph. In any case, I'll put that on its own sheet, and we'll just talk about this graph for a minute. You would need a title, and you would need a y-axis label, and you would need an x-axis label. Google didn't pick this one for me, so those are all under Edit Chart. Customize, where you can do the axes and the series labels as you've done before. But the kinematics is interesting here. If you graph position versus time for an object that accelerates uniformly, you get a curve. The reason is the slope of a position versus time graph is velocity, and for something that accelerates uniformly, the velocity steadily changes. So the velocity on this graph is betrayed by the slope, perhaps of line segments that join these. So up here, a line segment that joins these 2 data points is steeper, has a greater slope than here, the line segment that joins these 2 data points. So to reiterate, the slope of a position versus time graph is velocity. And if something's velocity isn't constant, then its position versus time graph will be curved. It will be curved in an upward fashion for an object that's speeding up, like both of these cars are, and will be curved in a downward fashion if cars are slowing down. Let me try one last adjustment to this. What happens if both of these cars start out going 27 meters per second, but then each slams on the brake at the same time, and we want to know how they're going to slow down? How do you do a deceleration? Well, if we say that these cars are moving to the right from our perspective or north from our perspective, and they're speeding up, then we know that acceleration and velocity have the same direction. So they're either both plus or both minus numerically, or they're both north if you're using words. If we want to describe something that's slowing down, we can give it a positive initial velocity and a negative acceleration. In that case, let's see what happens. Let's say they both slow down at a much greater rate, -8 meters per second squared. So that would be really slamming on the brakes from an initial velocity of 27 meters per second. Well, our charts update here. The Tesla and the Prius lines are right on top of one another now. We can see that they start at 27 meters per second, and since they're slowing down, as time goes by, the speed decreases. Now, for the car, they would hit 0 and then stop, not keep on accelerating backwards, but our equations of motion don't know anything about that. But this is to illustrate that when something is slowing down, if its speed is positive, its slope will be negative. And also, Our chart here has updated. They both are right on top of one another again because they both started at the same initial speed and they both decelerated at the same rate. And so here we see a graph where they start at 0 position and start slowing down. The slowing down is revealed by the changing slope between the points that the lines that join these two adjacent points. So more on this in a subsequent video. But at this point, if you can learn how to use Google Sheets to calculate formulas for you rather than having you just type in numbers, it will become a powerful tool for helping you explore kinematic and other quantities down the road.